Same change, also known as keeping a constant difference. So with this algorithm, I can add or take away the same amount from both numbers to make the computation easier. So let's talk about why I can do this. So let's say we had 8 minus 5. And for some reason, students don't know that amount. So let's go ahead and do the subtraction. 8 minus 5, 1, 2, 3, 4, 5, that gives me 3. And for some reason, maybe I don't know that, so I could go to a friendly number, 10, which would be 2 more, which also means that I would add 2 more to my subtrahend, 5, to get 7, and that should give me the same difference. All right, so 10 minus 7, 1, 2, 3, 4, 5, 6, 7, and I'm left with 3. Okay? So let's practice with larger numbers. Let's say we have 62 minus 17. Well, we know that with the 2 and the 7, I would have to borrow, and I don't want to do the borrowing. So what I could do is think about a benchmark number. So why don't I make the subtrahend a benchmark by adding 3, and that will give me 20. And I have to do the same thing to both numbers. And 62 plus 3 is 65. And so it's easier for me to subtract 20 from 65 than it is to subtract 17 from 62. So 5 minus 0 is 5, and 60 minus 20 is 40. Let's do 217 minus 96. Well, I see here I can do 7 minus 6, but with the 10 minus 90, I would have to borrow. So if I do the same change or keep in a constant difference, I can make my subtrahend a benchmark. And the closest benchmark is 100, so I would need to add 4. 96 plus 4 gives me 100. And I need to also add 4 to 217. So 217 is in my head, 218, 219, 220, 221. So your students could still fairly easily compute that. 1 minus 0 is 1. 20 minus 0 is 20. And 200 minus 100 is 100, which means that 217 minus 96 is also 121.